I'm Jane Morris, and in this presentation I'm going to discuss issues that relate to the risks of releasing GM crops that have wild or weedy relatives in the southern African region. To set the scene, none of the genetically modified crops that are currently available have wild relatives in the region, so that includes maize, cotton and soybean. However, publicly funded research programs that are targeted towards small-scale farmers are more likely to involve crops that have wild relatives. The first example of this was the African Biofortified Sorghum Project, funded by the Bill and Melinda Gates Foundation. In the case of the Sorghum Project, the South African regulatory officials imposed extremely strict containment requirements for experimental work. This was because of their concern about gene flow to wild relatives. However, the issue of gene flow needs to be taken in context. It has to be recognized that gene flow between cultivated crops and their wild or weedy relatives occurs in any case, independently of the issue of GM crops. There are many examples already of genetic mixing and the formation of invasive hybrids through natural processes, but there is no regulatory oversight in this particular case. So this is an issue that has only really come to the fore with the advent of GM crops. If we accept that gene flow is going to happen, we can then question whether it is necessarily a bad thing. We need to take into account that the genome of any species is constantly changing, so talk about genetic purity is really untrue and inappropriate. In fact, gene flow is an essential component of evolution. In some cases, transfer of genes for disease and insect resistance may protect wild species and help to preserve biodiversity. One example that's been given is of the new wheat rust UG99 that is spreading around the world. Many wild relatives from the centre of origin and biodiversity of wheat were screened for possible resistance as a hopeful solution to the rust, but in fact almost all strains were highly susceptible. If UG99 rust gets into wheat fields, the nearby wild strains will be devastated. If wheat is rendered UG99 resistant, the resistance will spread to the wild species and possibly save them. If the wheat is rendered UG99 resistant by breeding, there are no hurdles to immediate deployment. But at the moment, if done transgenically, the wild relatives would probably be devastated by UG99 by the time regulatory approval is achieved. When we consider gene flow, it's useful to distinguish between the different types. Vertical gene flow occurs between sexually compatible individuals. Horizontal gene flow is flow between non-interbreeding organisms, such as between plants and bacteria, but it's not a major concern for regulators as the likelihood of occurrence is so low. Diagonal gene flow occurs between related but incompletely compatible species. In most cases, the hybrid is sterile, but it may also occur through an intermediate bridge species. So, in the case of crops with wild relatives, we're really talking about vertical gene flow, but with some possibility of diagonal flow. Introgression is a result of gene flow, where there is permanent incorporation of genes from one population into the genome of another population through a series of crossing and back-crossing events. However, many gene transfer events are likely to be unstable and would not lead to permanent introgression. So, the likelihood of introgression will be affected by the reproductive biology and fitness of any hybrid, but also by reproductive biology of the crop, including the mode and distance of pollen spread, and the presence of sexually compatible wild relatives within reach of the pollen. The potential risks of introgression have been described as follows. Firstly, if introgression occurs in a weedy relative, that is, one that is growing in a cultivated agronomic area, this could eventually lead to positive selection and dispersal of the trait that was transferred and result in increased invasiveness. Similarly, if introgression occurs in a relative that is wild but not weedy, i.e. not growing in cultivated areas, then depending on the trait involved, it could potentially become weedy and invasive. On the other hand, a wild relative could be placed at a disadvantage through the introduction of the new genes, resulting in negative selection and what's known as demographic swamping, by which other species would outcompete it and potentially lead to extinction. So, are any of these scenarios likely to happen? Well, firstly, there is so far no evidence of any extinction as a result of introgression with wild relatives. Herbicide and insecticide-resistant transgenic hybrids between weeds and crops can show higher fitness than non-transgenic weeds in managed agronomic settings, but there is no evidence that they become more invasive and spread in the landscape. Considering that introgression will occur, a variety of mitigation strategies have been proposed. These include male sterility, which may be cytoplasmic or genetic, chloroplast transformation, delayed flowering, transgene excision in pollen, cleistogamy, where flowers do not open but are self-pollinated in the bud, selectively terminable transgenic lines, for instance sensitive to a specific herbicide, or total sterility, but this is not applicable where harvested material is the seed. Unfortunately, at this stage, none of the mitigation strategies seem to be 100% effective. The strategies for containment can be biological, chemical, or physical, but they all have associated risks. Certainly, just adhering to isolation distances observed by breeders can do a lot to reduce gene flow. But in the end, risk assessors need to consider the consequences of gene flow, not just the likelihood of it occurring. Let's look at the example of sorghum that I mentioned earlier. Firstly, Africa is the centre of origin of sorghum, and there is a large number of sexually compatible weeds, wild relatives, strains, and races of cultivated sorghum. Sorghum is largely self-pollinated, but wind pollination does occur. Pollination drops off above 40 meters, but breeders use a distance of 100 meters to achieve less than 1% outcrossing. In addition to this distance, biological containment, such as using male sterility, could reduce the gene flow still further. So what are the risks associated with introgression to wild or weedy relatives of sorghum? Well, introgression of multiple herbicide tolerance genes could be a major problem for control of weedy relatives such as Johnson grass. On the other hand, if we look at the example of biofortified sorghum, introgression of genes for nutritional enhancement would not give weedy or wild relatives any advantage and could be considered neutral. And as I said earlier, any introgression needs to be considered in the context of commonly occurring hybridization that occurs in the absence of transgenic traits. So, to sum up, firstly, it should not automatically be assumed that if a GM crop has wild relatives, that permission for environmental release should be refused. Instead, each crop and trait combination should be considered individually on its own merit. Risk assessors should consider the harm that would result from introgression and distinguish what will change from what harm will occur. Risk is then determined as a combination of the likelihood and consequence, and if the negative consequences of introgression occurring are considered to be minor, then the overall risk may still be low. Thank you.